Okay, I wanted to actually start off by asking if anyone had questions regarding that Python code challenge that you guys just had, because that does introduce topics, and I'm not really gonna go over all of those. In fact, I'm not really going to kind of exhaustively run down all the new um, concepts you guys are going to see in Python. Because there are a number of good resources out there, including our own. Oh, I need to find that one sec. Oh, it's so like for example, we have a pretty good JavaScript to Python conversion cheat sheet for you to reference. Um, there's lots of good resources out there as well. It looked interesting, so that did not remind us. I see. Okay. I'm looking for. Okay. Sure. This is another link that just kind of goes over some snippets in Python code to JavaScript. So there's like lots of these sorts of resources on the web. Uh, I think whatever you want to try to do in JavaScript, it shouldn't be too hard to figure out how to do the analogous thing in Python. But I guess that does segue pretty well into the first thing I want to talk about, and that is kind of how you kind of go about learning a new language as a developer. Um, because you can be smart about it. There's a bit of a process, right? So, for example, every language in use is going to have your for loops. It's going to have your while loops. It's going to have your conditionals. It's going to have your arrays and your objects or something equivalent. So these are things that every language includes. There might be like tiny, small kind of like implementation differences. So let me share my screen real quick. So for example, here let's just open up a Python 3 REPL. So just like, for example, what I mean is like in JavaScript, if you have some array and you want to find the length, you do a dot length, right? That's how, if I can spell that correctly, that's how you find the length of an array in JS. In Python, you just need to get used to instead wrapping that in a function like that, because they have this function called len. Then you give your array as input into that to get the length, right? You're still just finding the length. It's just a slightly different way of doing it. It's a slightly different syntax, right? But point being is that there's going to be analogous ways of pretty much doing whatever you want to do in the language you're comfortable with in the language you're learning. So you just have to reference or look up exactly how that's done, right? It's really easy to go and write, how to write a for loop in Python, or how to write a while loop, or how to write a ternary statement in Python, right? Again, you guys have this notion of kind of tools that are available to you in JavaScript, and you have an idea of when you'd want to use them in JavaScript as well. So when you're learning a new language like Python, it's important then to be like, okay, here I would use this language feature if I was writing JavaScript. So now how do I actually do that in this new language I'm learning? So again, I'm not planning on running down kind of all of the differences, or like, for example, I could walk you all through this reference sheet, but I'm not going to, because you all are perfectly capable of reading and I don't think it would be particularly interesting. So, but of course, please reference this whenever you're working on learning Python code. It's going to be a valuable resource, as well as all the usual kind of avenues like Googling and Stack Overflowing. Again, I just want to kind of introduce you guys to the fact that in the CS curriculum, we want to try to make you guys more self-sustainable and a bit more self-reliant. So that kind of encompasses, trying to push you guys to first try to help yourselves before asking help from others. And that's definitely not to say do not ask help from others. Please don't take it that way. I just mean your first line of defense should be doing a little bit of research. So again, the rule of thumb we keep in mind is maybe like between 10 and 20 minutes of research on your own first to try to figure out the problem you have. And if after that point you haven't found anything, then definitely do please reach out in the help channels to try to get you unstuck, right? So part of that is knowing what sorts of resources you have available to you. Okay, so first off, let's pivot a little bit. I want to talk a little bit about the Python language in general, and kind of what are some of its major kind of key differences between Python and JS. So I'm going to assume you all already installed Python 3 and have pipenv running. If you haven't, again, either reach out in the help channels for help getting that installed or ask your PM for help. But I'm going to assume that everybody has that. Okay, so I think Python, it turns out Python is actually older than JS, right? Because JS came about in, I think, 95. And I think Python first came about in like 91. So it actually turns out it's a bit older. But what's really interesting about Python, and I guess if you want to kind of get an idea of the philosophy behind the language, you can always just open up a Python replit like what I've done here, and you can go and just type import this. If you enter that, this gets you a cone, I don't know what you want to call this, called the Zen of Python. I don't think Tim Peters is not the progenitor of the language, but I think he just wrote this. But it really does give you a concise and rules of thumb as to how you basically want to start thinking about writing Python code, right? So it turns out, and if you read this, you get this idea that Python tries to be explicit and it tries to be concise and expressive, and most above all, it focuses on readability. Right, as it says right here, readability counts. And really, at least from my own personal experience of seeing the number of languages that I've seen, Python really is the language that comes the closest to just like plain English. So in that front, you're not going to get any better than that as far as, again, like pure readability from a language standpoint. So what that basically translates to, for example, is like for loops will look something like for, item in array, for example, right? We don't have the C style for loops of like in JavaScript, something like this, where there's a lot of punctuation, there's a lot of curly braces, things like that, right? In Python, it's a lot cleaner for thing and collection, and then you use colons instead of kind of like parentheses to denote the end of that statement, right? So like, again, for example, if you, at the end of a for loop, use a colon. At the end of an if, use a colon. at the end of a function, you also, well, you have your parens, input, and then a colon, right? So there's no curly braces denoting function bodies or scopes or anything like that. That's all just done with white space. Python doesn't really care whether you go with indentation of 2 spaces or 4 spaces. Although I think it does care that you use spaces instead of tabs. As long as you just keep your indentation spacing consistent, it doesn't care. But white space is important. Otherwise, your program will just not do the thing you're expecting it to do. Because if you mess up the white space, it's like if you left off a curly brace in JavaScript code, right? Then it just means something totally different to the interpreter. Which I think is nice, and I think it's nice that we teach you guys Python then, because it forces you to indent and format your white spacing properly. Because I know before that, for you iOS students, I have no idea if I really know nothing about iOS, or about Swift, I should say. So you'll have to forgive me on that front. Like, I don't know if Swift cares about white space or not. But yeah, on that front, with JavaScript, because JavaScript doesn't actually care about white space and indentation and stuff like that, you can get away with writing some pretty messily formatted code. Right, so making you guys write Python, I think, will force better habits. Okay, so again, very much like JavaScript, just like how in JavaScript you could bring up a REPL really easily with just node. Again, so we've seen the same thing already with Python. You just type in Python or Python 3. It kind of depends on what you have installed on your machine. So it'll bring up a Python REPL. Python obviously cannot be run in a browser. So that's obviously the major difference. Oops, what does it want? It wants exit node. I'll just Control C. So I think really, and again, there really isn't much that separates Python and JavaScript in terms of what one language can do and what one cannot. Well, I should say, okay, sorry, let me back up a bit. So obviously you can run JS in a browser. You can't do that with Python. But what Python is better at, in contrast, is it's much better at like arithmetic, for example. I don't know if you guys have heard that, for example, JavaScript is typically you don't want to do any sorts of precise calculations in JS because of JS's policies with rounding. It's not very precise. It's a little bit ambiguous on that front. So JavaScript is not very precise when it comes to doing arithmetic and stuff like that. Python's a lot better about that. And it's also because it's a lot more readable and closer to English. It's really gained a foothold in the academic community. So academics, when they need to write programs, it's very often they'll do it in Python. And so there's a much more kind of mature ecosystem in Python for doing things like data science and machine learning and things like that. So if you were interested in, again, data science or machine learning, you'll definitely need to get comfortable with Python, as well as some of the major kind of Python math libraries like NumPy and things like that. So those are very common in those realms. So that's kind of the thing that Python has over JS is it has a different kind of domain focus. So So what I thought we would do to kind of get you guys situated and start reading and writing some Python code is I thought we would look at some of the old JS challenges, code challenges that you guys saw before. And again, I have to apologize for the iOS students. We won't spend too much time on this. We'll transition to the Python pretty quick. But I thought we would quickly kind of refresh your guys' memory on some of your old JS challenges. Write out a solution real quick in JS, and then take that and basically see how we would do the analogous, how we would write the same solution in Python. Okay, so does anyone recall this particular code challenge? This is the one where given two arrays, you had to find the common elements and then return an array with just the common elements in array 1 and array 2. So if anyone recalls, what's kind of your line of thinking as to what you do in order to solve this particular challenge? I'm asking you guys if that wasn't clear. Tom says inner for loop. Okay, so before we even get there, we need a for. Okay, so you'd say for. So you say inner for loop, meaning that's a for loop inside of a for loop, is my guess. Yes. Okay. So Tom suggests a for loop inside of a for loop. Sure, we can do that. So we can initialize a for loop. Let's say array 1 length. And then he says another for loop. Okay. So what this would allow us to do is we're iterating along all the elements in array 1, and then we're looking at every element in array 2 and trying to see if you could also do one loop using includes. Okay, sure. We'll write that real quick. Linda says initialize an array. Okay, I would agree with that. So let's call it answers, or I just say matches. Okay, so that's going to be the array we're going to probably push matching elements to. And then in here, we'd probably do something like if array 1, if the ith element matches array 2, j, we can matches dot push, doesn't really matter, array I. Return matches. Let's just make sure that that works. Okay, so that works. There's also another suggestion for using array includes. So common elements. Do one loop using include. Oh, I see. Okay, so let I equal. So we'd still need the const matches here. And then if oh no, we'd want to do 2 dot length I plus plus includes array 2I. Then we can push array to I. And matches. Okay, so that works as well. Remember, search of this challenge, array 1 through 4 and array 2 or something 4 2 4 expects only. Okay, let's not worry about that. So we've come up with 2 ways in order to solve this. You can do with set intersections as well. Good point. Okay, oops. So let's open up a new REPL. Let's see how we do this in Python. So let's open up a new one. So here, let me just go and copy this over. So let me just put this in a comment string. And as you saw in the code challenge you guys had earlier, to do comments, to do block comments in Python, you use quotes, and the pound symbol is for normal comment, one-line comments. But anyways, so here we want to define a new function called common elements. I'm going to use snake case because that's the convention in Python instead of camel case. So array 1 and array 2, colon. So that'll be our function signature. So first off, let's opt with let's translate the first solution that we had. So using the two loops. So again, we're going to have an array matches like so. Again, in Python, there's no keyword to declare variable. You literally just say whatever the variable name and do the assignment. So, and then we're going to loop over all the elements in array 1 first. So let's say I in array 1. So this is just looping through everything in array 1 and putting that in this I variable. So this is not an index. I should probably name that better then. So let's say Python enforce types. That's a good question. I'm going to call it item 1. It does not enforce types. Very like what JavaScript does. Python does type inference when you actually run the code. So when you actually go and run the code, it inspects what your code is doing. Like for example, it'll look at this line. It can see that the assignment is being set to a list, and I should start calling them lists and not arrays, because in Python arrays are called lists, and I should use the appropriate terminology. But it'll see here you're doing an assignment to a list, and it will then know to set the type for matches to be a list. So it's smart enough to figure that out. So no, it does not enforce types. It's like JavaScript in that sense. Is match not mutable? It is mutable. It's mutable. Oh, there's no distinction between like a const or a let here. It just does this assignment, and we can add to this list. If you assign a different type, can you change types at runtime? I don't see why not. Yeah, you're definitely able to change types at runtime. Like later on, we could go and like matches reset that to something else, and that's totally fine. Okay, so we have our outer for loop, no worries. And then we'll have our inner for loop. I'm going to call it item 2 and array 2. Yeah, you could do that. That is all valid syntax, yep. And then here we will do if I've already blanked on what we wrote earlier. Hold on. Okay, if the items match, yep. So if item 1 matches item 2, so note there's no triple equals in Python. If you want to do equality comparisons like this, it use double. Yep. And in fact, I think from what I know, JS is one of the few languages that actually even uses triple equals. So in that sense, it's a bit of an outlier. Most languages just have a double equals. But then if, for example, real quick, as a quick aside, if you wanted to, for example, do 2 object comparisons. So for example, if you wanted to check that 2 objects were the exact same spot in memory in JS, that's what the triple equals is for, right? To do the same thing in Python, you would use this is keyword. So that would basically be doing the same thing as triple equality, but it's fine if you don't remember that later. I'm just gonna say it for posterity. Okay, so if item 1 matches item 2, then we can say matches dot, and instead of a push, they have the method is called append. It doesn't really matter. So we'll add the item to the matches list. And we'll return matches. Here I have some. Let's run some print statements. Print is basically the same as console log. So whatever you want to print, just wrap it in that function, and we'll call common elements with some test cases. Run that, and I think we get exactly what we're looking for. So 3 and 4 are in both. A is in both, and then there's no commonality in the last one. So that is one way to do it. Again, this is pretty much a straight port. Is it important to have 2 new lines? Is it important to have 2 new lines before? You mean like that? Or you mean that? No, so you don't actually need the new lines. That works as well. I just do it for better formatting. Yeah. Like for example, if we want to go and define another function, it doesn't matter how much space you have here. It will then just look for another function body and what the indentation level of that is to denote that we're, for example, starting another function definition. Of course, you're not really going to have that sort of white space. You might just do that. For example. So let's comment that one out. Let's implement another one of the suggested ways of doing it. So we also had an includes, and I should probably, I don't know if Python has a includes method. Includes. So let's look that up. Okay, so I wasn't sure about this, but we can just use this keyword in. So let's try that. Yeah. So for item in array 1, we can then say if item is in array 2, matches append the item. And then return the matches. So that also works. And then let's also do one other suggestion that was given from Brian, which is to use sets. So it's a shortcut for commenting out. Oh yeah, so what you can do is just highlight the whole thing, the whole body, and at least on OS X, you would do command // is the shortcut. But I do not know what it is in Windows. Okay, cool. So again, with our matches list, and we're also going to initialize a set. So sets are pretty nice for this sort of problem, because what sets are good at are just putting things inside of a set and then checking if the thing that we put in is in that set. It's more efficient at doing that sort of operation than a normal array is, for example. Even though both arrays and sets can do it, a set is actually more efficient at doing that. So what we can actually do is we can just feed the set one of the arrays by just passing that into the method. There's also no new keyword, so new doesn't mean anything. You just initialize whatever the class, like so. So once line 25 is run, we have a set with all of the things that were in array 1 now inside of the set. And then we can just say for item in array 2, if item is in S, we can append the item. Uh-oh. Name error name set is not defined. Okay, do I need to go include something? Let me see. So is everything initialized on the stack or will it be in the heap? Lowercase? Oh, you're right. Actually, you're right. Sorry. You are right. It's a typo on my part. Yep, okay. So again, different ways of doing it. We had a loop inside of another loop. We had one using the in keyword, which is analogous to the array includes method in JS. And we also used a set. types may be. So this is I mean, it is okay. It is a type, but this is more specifically. This is a data structure from the standard library. So yes. So like for example, as well, you might also see syntax like this, which is exactly the same as so sorry, when you do empty brackets like this, that's the same as doing it like declaring an empty list. So we could have just also done that. And that'd be the same thing. So yes, those are lowercase, and also Python's equivalent of objects are called dictionaries, and you could initialize an empty one with dict, like so, or with the more usual curly braces notation. Is type inference? Yes. I'm not even sure you have the option of declaring types if you wanted to. That's a good question to ask, actually. Not much. For all intents and purposes, you can consider them pretty much the same thing. Just different languages give them different names. But yeah, with lists and JavaScript arrays, you basically can do the same things. You can take the lengths, you can add to them, you can pop off of them, you can shift from the front. Pretty much most of this, they can do most of the same things. Travis asks, is there a point in using a set as opposed to just saying if item in array 1? That's a really good question. I guess for me to fully answer that would necessitate knowledge that you guys haven't received yet, more specifically when you get to algorithms and data structures. You'll see that there actually is a difference. But I can break it down. I can break it down a bit. So I think you guys have probably heard that, nested loops are not a good thing, right? Because what this means, I want to, you'll see that I have this little tablet. I really like drawing on it for lectures. So let's do that here, because I think a visual would probably be good. Okay. So let's take an example, right? So an example of just running the first snippet that oh, come on. Sorry, I think when I updated my OS, started making the tablet behave kind of wonky. Let me see if I can troubleshoot that real quick. Oh, man. Okay, now it's working. Okay. Okay. So hopefully that works. Okay. So let's take, for example, we have 1, 2, 3, 4 from this example here at the bottom, and then why does it do? Sorry. And then we have the 3, 4, 5, and 6 example. Right. So what we're doing in this body is, first off, if this is array 1 and this is array 2, we're looping over everything in array 1. And then because we have a nested loop, then we iterate over everything in array 2. Right? So we're starting off at 1. And then from there, we're iterating 4 times. And then we go to item 2. And then we iterate 4 times again. And then we go to item 3, we go to item 3 in array 1, and we're iterating again. And then we go to item 4, and then we iterate over everything again. For those of you that are paying attention, how many iterations, how many times do we iterate in total? So Brian is correct. Right. So Brian is correct, as well as what David says, right? We iterate over items in array 2 once for each item in 4. So there are 4 elements in array 2, and we iterate over these once for each of these in the outer array. So 4 times 4 for 16 total. Okay. And then when we do, it's actually the same thing when we go with the second option. So really, when we say this line here, if item in array 2, I think under the hood, this is just doing the same thing as what we did here. It's going through everything in array 2 and checking if the item is in array 2. So I think really our first code snippet and our second code snippet are pretty much doing the exact same things. It's just we're just using some syntactic sugar in order to do the same thing that snippet 1 is doing. So actually using a set is different. Okay. So if we examine what we did here with the set, we initialized the set, and we fed an array. So when it does that, it'll loop through everything in this array and put each of them inside the set. So again, let's go with our 1, 2, 3, 4. Right. So it iterated. We had 4 iterations just to put all of these inside of the set. And then we come to here. Right? There's no nested loop here. Right? We just go for item in the 3, 4, 5, 6 array. So we iterate 4 times here, and at each one we do that check to see if item in S set. So it turns out with a set, and when we do this in operation with a set, it does not need to actually look through every single item. It actually is able to just grab the item immediately, right? So we iterate starting at 3. It can immediately check and find that 3 is in here. It doesn't need to go and loop over everything. So we say if item is in set, it just says yes. We get that back immediately. We don't need to go and look at every single item. We don't need to go and inspect each of these one at a time. and then it happens 4 times, 1 for each of these. And so in total, does anyone know what's the total number of iterations then that we performed? No, there was the iteration to put everything in the set, and then there's iterating along array 2. Yep, so 8. Yeah, you don't need to perform a linear check with a set. So for set, it's not looping under the hood. That's a little beyond the scope of this lecture. Again, I know we've kind of deviated into it, but this is not actually a data structures lecture. But you can definitely do research on that on your own, Brian, to maybe try to figure out how that happens. But again, a little bit beyond the scope of what we're going to be talking about today. Right, but again, point being was that with the first snippet and the second snippet, these each performed 16 total iterations. With this one, we need to only perform 8. So with this one, we do less work. Hence, it's more efficient. Anyways, that's all I'm going to say on that topic. But that's a short answer kind of what the difference is and why it matters. Okay. Let's move on to a very similar kind of problem, which I think you guys have also seen before. Again, sorry to the iOS students. I'm going to do this in JS real quick. So very similar question, right? Except here, well, we're being given a string, and we just want to count the number of vowels in the string. So, or say count, and we don't want it to be a const. So initialize a count, and then what's the suggestion on what we might want to do next? Okay, we can declare what a vowel is. So let's go. Let's go A, E, I, O, U, and Y, and then let's also throw in capital versions. / what vowels are. Yep. Okay. So once we've done that, then what? Oh, for the purpose of the extra, not considered Y as a vowel. Okay, fine. Iterate an if check. Okay. Y is a vowel. It's sometimes a vowel. So iterate along the length of our string. And then we can say if string I in vowels, we can iterate our count. Yeah, that's pretty much what we're doing here, right? Uh-oh. Oh, can I use property? Can I use in operator? Okay, apparently it doesn't like that. I guess we could go and use includes. See if that works. Okay, that works. It just doesn't like using in. Okay. Okay. Sure. So that works. Maybe. Unintentionally. Okay, so again, it should be pretty similar in terms of the Python code. So val count, let's call this one a string. I think str in Python is a keyword. So we'll have a count initialized to 0. We can again do vowels. And then for char for character in string, if char is in vowels, count plus equal 1. So another thing to note, in Python, you cannot do count plus plus. That is not a thing. So you have to do plus equal 1 or plus equal whatever. That's kind of part of Python's readability philosophy, that maybe count plus plus might be a bit more ambiguous than count plus equal 1, which I can kind of see an argument for. So just try to remember that you cannot do plus plus, but if you try to run plus plus, the interpreter will tell you anyway. So let's try that. And we get 16 and 1, which I think is correct in the case of supercalifragilisticexpialidocious. But I don't think I didn't actually count it myself. Okay, so that works. And we can also, again, use our good old friend, the set. Because as we see here, right, with the same principles of what we were just talking about with the previous example, if we do an in with a vowels string, it's actually going to check each one individually. So it's going to have to iterate through this list of vowels, this string of vowels, in order to do the actual in check. Right, so we can notice here that because we are basically checking a string or a list in the case of the common elements problem, we're checking something for membership, right? Within, and when we notice that, that should actually clue us in on maybe we want to use something that's better or more efficient at being able to handle checking for membership. So let me just add a comment here that says sets are really good at checking for membership, which is why we use it, which is why it's very applicable here. So again, we can say s equals set. We can throw in our a, e, I, o, u. straight into the set. Initialize our count, and then do the same thing. Oh, I'll call it set. And we get same answers. How does the initializer know you're not trying to create a set containing one string element? I guess because if you wanted to do that, you would probably have to do it differently. I think if you want to do that, you'd probably have to do something like set dot, you call set dot add and then a. Although even then, I'm actually not. Oh, but this is 2.7. We want 3.7. Ooh. Standard library. No difference. One sec. So set, actually let's look for add. Nope. Set. Oh my gosh, come on. I think you just have this string, I'll iterate over it, but not with add. Yeah, that's what I'm thinking as well. I'm just trying to confirm that, and it's not making it easy. I was already on this page. It's dictionaries. Sets, add, set. Okay. I probably should have just done that. That probably would have been easier. Thanks, Brian. Okay, but yeah. So yeah, to answer your question, Andrew, you'd want to call the set add method. Yeah, you'd want to use set add instead of just passing into the constructor. Okay, so let's get into. Well, actually, let's take a 5-minute break, and then when we come back, we're going to talk about a few other handy features of Python that I think are pretty much entirely new if you're coming from JS. Again, I have no idea about Swift. Maybe I should probably get an understanding of how the Swift language works for future times I teach this. But anyways, it's different, not most. Yeah. Okay. So put a 5-minute timer on, and we'll come back in 5 minutes. You can still ask questions if you want while you're here on the break. I don't think I'm going anywhere. Nice. You could also use indicating a tuple. Oh, I see. So that'll do the same thing as if you just called the set add. Okay. Should try that for myself. Okay. Wait, no, that's still. Oh, I put it in the. Okay, my bad. That. Still gave me the same thing. Set descriptor add requires. Oh, sorry, my S. So let's do that again. Yeah, it looks like I need to call add. It doesn't seem to work otherwise. Okay. Okay, so that'll work. Okay. Gotta put in a list first. That's good find. Okay. So let's come back. So next up, what I want to talk about, again, some of the kind of handy features that, or I should say handy kind of syntax shortcuts that Python makes available to you that I don't really think exist in JavaScript. So for example, let's create a list. Just throwing a couple of numbers in there. What's really nice is we can do things like, well, Python's a really nice list and string slicing syntax. So for example, if we wanted to return the very last element in the list, like we want to do that in JavaScript, for example, we would index it by like length of the array -1, right? But in Python, we can just give it -1 as an index into the array. And that will just automatically give us the last thing. And there's also some nice slicing syntax. So for example, if we just wanted like a portion of the array, so let's say 3 to 4, for example, we could do the list slicing syntax like this. So the index would be 0, 1, 2 to 4, I believe. And if we print that, we get 3 and 4. Right, so what we did here with this print, let me see if I can blow this up. Okay. So with print the list at indexes 2:4, we're basically saying, give me a part of the list L between or starting at index 2 up to but not including index 4. Right? So index 4 is the 5. So we just looked at the indices 2 and 4. We get these 3, but with the slicing syntax, it doesn't give us what's actually at index 4. It gives us everything before that. So just 3 and 4. So I think this is a much cleaner kind of shortcut or shorthand for doing list slicing and things like that. And so we could also do print. So let's say if we want everything in a list but the last element, we could do 0:-1. And so that will give us everything but the last 7. Or we can just shorthand that even more by not having to include the 0. So we don't include anything on like the left side of the colon, for example, then it will just assume we mean start at the beginning of the list and give us the same thing. Okay. Again, just handy kind of clean shorthand syntax. Don't feel like you need to have all this memorized. I'm just letting you know that this exists. And with the expectation that in order to really kind of start making use of this in your own code, you need to actually practice doing this yourself a number of times. It's not like once you see it, you're going to be doing it, using it in your code all the time, which is not the case probably. I just wanted to make you aware that this is a thing that you can. This is the way that list and string slicing, because this also works on strings, is how this works in Python. So later on, when you want to do some list or string slicing in Python, oh, I can look up this the way this special shorthand works and try to practice that a bit. I also realized I should probably show you guys how a for loop actually a normal for loop like one in JS works. Like when you just for example, with JS for loops, we always use there's always this index I, right? That's always there. Whereas, with the for loops we've seen so far, there's no notion of an index. So what if we wanted to make use of just an index in a for loop, right? So the way to basically get this exact same functionality from this sort of for loop in JS in Python is we would do for I in range length of the array. And then just like we said, for example, like console log I. Then here we could just do print I. And that'll just print out this index. So let's run that real quick in the REPL. So we'll say length of L print I. And then that would print out all the indexes for us. So Python makes use of this range function, which is basically going to give us the range from, well, so in this case, because we just gave it one argument, it assumes that this length of array is going to be the end of where we stop at the range. So basically it's shorthand for 0 length of array. But we could also change that if we wanted, for example, to just iterate from 2 until the end, right? So we could do 2 print I. And then it just starts from 2 instead of starting from 0 here with this one. So I want to show another thing in JS that you might do. So let's say, for example, you wanted to fill an array in JS with a bunch of indexes, right? So let's say we wanted to do const array equals, let's just initially have it be empty. And then here we can array dot push the index, right? So we don't want to array length. Let's just say, let's say 10, right? So we know what this will do. This will put 0 through 9 inside of our array. We can, of course, do the same thing in Python with, so let's say empty array for I in range, here will be 0 to 10 again. Array.append I. Then we can print the array, and we have 0 to 9. Okay. So that's one way of doing the same analogous thing. But I want to show you a better way to do it in Python. So in Python, there's this really cool language feature called list comprehensions. And so let me just show you what it would look like first. A better way to do it in Python. For I in range 0 to 10. Let's call this R. And then we can just print R, and we get the same result. So what we just did here is what's called the list comprehension. And again, basically what Python allows you to do is we can take this expression, I for I in range whatever, and we wrap that in brackets, then it will take whatever this expression evaluates to and put it all inside of an array automatically in one line. Right? Instead of having to do what we did here with a for loop along a range and then calling append, we can shorthand that like this. So let's yeah. So basically, anytime you want to, initialize some non-empty array with some values in it, you would pretty much do this. You'd use a list comprehension. Does this apply for other? Yeah. So you can literally do, I think, like any sort of expressions. So let's show a few more. Get rid of that. So let's say, for example, let's say list comprehension to init a list with all the numbers between 1 and 1,000 that are divisible by 7, for example. We can do that. I'm going to call this array D7, and we'll just fill a list with, let's say, num for num in range 1,000. So this on its own is going to get us everything from 0 to 1,000, right? So if you want, we can just make sure that we see that that's what it's doing. Let's comment everything else out. Yep. So we just initialized a list with 0 to 999 with this one line. But then if we want to do the divisible by 1,000 bit, we would just add if num mod 7 equals 0. We can add that logic just right into the list comprehension. Now we print D7, and we get 7, 14, 21, et cetera, et cetera. What's the first? Well, okay, so for example, if we just did that, well, okay, let's go back to just this. Okay, so we just have this. Sure, so we declare this num, which is whatever number we are currently iterating on as we are going through this range. But if we do this, well, I should just count this invalid syntax. Basically, we need num here first to tell it that this num, we want that inside of the list, basically. This is what tells it. So it'll evaluate this expression. It'll figure out what num is, and then it will take num and then put it in the array, in the list. Well, num here, I don't know if I'd call it an object. I mean, again, if we just have this, num is the current number that we're iterating on in this range, right? And then we need it in the front to say, okay, now that we have that number, just put that in the list, basically. Again, I know this is going to take practice on your guys' part. I just kind of want to show you what list comprehensions are kind of capable of. Yeah, it's the declaration of taking that numbered value and putting that inside the list. So we change the first num to 1, would it? Yes, it would, actually. Yep, exactly. Yeah, that's a good way of putting it, Tom. Kind of. Yeah, evaluate this, whatever it returns, put that return in yeah, return that for this current iteration of like the list comprehension. Sure. Let me put that back to what we had. And let's write a few more. So we could say like list comprehension to init a list with, let's say, for example, okay, so let's say string, let's go back to supercalifragilistic. So let's take that as a string, and then let's initialize it with just consonants. Again, we'll need vowels again. Actually, let's go back to using our set. Let's go back to our set just for vowels, and then we'll say, we can say letter for letter in string if letter is in S, or if, sorry, I should say not in S. Okay, so this is going to, if we just examine again the expression, let's just look at this part here. We're iterating along the string. Each letter we're looking at is called letter, and we check to see if letter is not in S. If you want to do a negation, which is the analog, which is the bang in JavaScript, you actually just use this not keyword. So again, going back to the whole like Python is basically just like English in many ways. It's a lot more readable, right? It just means exactly what it says. Then let's print that, and that, I mean, that looks correct. So you can get pretty expressive with whatever you want to put inside of a list comprehension. If you want to get, you know, fancy with your list initializations and things like that. Pretty much anytime you do some logic to like initialize an array, a list in Python, you could probably do it in a list comprehension instead of using like a for loop or something like that. We're not going to, well, I don't want to get into it too much, but you could actually also do the same thing with dictionaries, with objects, I should say. So for example, if we wanted to get so this was actually in the Python code challenge you guys just had. So if we wanted to say initialize a dictionary, which again is an object in JavaScript, with something like, so for example, we could do x colon x. So the first x is the key, the second is the value for x in range 100, or let's just call this D for now. Print that. And then we get 0, 0, 1, 1, 2, 2, 3, 3, all the way up to 99, 99, for example, right? We can modify this. So let's say I want the key to be the same x, and then the value to be the value if I squared that x. And for that, I could just do that. right? So now x is just still the same value between 0 and 99. And the key is going to be that same number squared. We're going to run that and get 00112439 et cetera, et cetera. Yes, I believe so. Like we could do, yeah, so you can do it this way. I'm pretty sure there's also a power function. Oh, square roots. There's definitely a function. There's a math library with a square root function. You can also do, yeah, math.pow x, I think 2 or something like that. So there's a function for it, but here you can also, yeah, use the asterisk shorthand. Yes, snake case rather than camel case. Lol, I just realized that. Okay, one last thing I want to mention are anonymous functions in Python. So I think we all know and love anonymous functions in JS. Let's just call it non. For something like that, closures in Swift. Okay, yeah. So, you know, let's just call this identity. So just an identity function, takes some input, returns the same thing. We've seen these before. So let's see what it would look like in Python. Tom knows where this is going. How could I not talk about this? Yeah, so let's define the same thing. Let's give it the same name. We're also going to call it identity. And yeah, they use this lambda keyword. And this is a reference to the lambda calculus, which was the name of the mathematical notation that was invented by Alonzo Church that basically was the progenitor of anonymous functions in programming languages. Not going to get into the math behind it. But basically the syntax for this would just be lambda, whatever your argument, so input, x in this case, colon, whatever you return, right? So let's say const print x in console log x, print, oh, I can't call that print because that's the name of a function. Let's call it log. It would just be lambda x print x. So then, of course, we've seen instances where, like for example, if you wanted to run like a filter function, you would pass it a callback, and we might define that, you know, as an anonymous function. X. Let me see. So so like if we were filtering some array, then it would be and this is still in JavaScript. So we could pass it a callback and say x not equal to some y, for example. Or, right, you could do the same thing then, where if you wanted to call filter on some list, then you'd pass it a lambda x, and then return x not equal to, I don't know, some y, for example. I don't think that was a very good example, but just like with anonymous functions being passed in as callbacks to like array methods, for example, you would do the exact same thing with lambda functions in this case here. Can I do another example? Do you have one in mind, or just any example? Any for lambda functions? Let me see. Yeah, so let's see. Maybe a sort. Yeah, we could do a sort. So, like, for example, let me see. Now let's do a. Well, let's hold on. Let me do a more concrete example of this filter that we just saw. So let's actually run something with the filter. Okay, sure. So let's say. So let's say we have an array like this, which is filled with the first couple of Fibonacci numbers. Let's go and filter out all the odd ones, right? So we can do result, and actually we can combine this with the list comprehension. So we can say result inside of a list, we're going to call filter with a lambda, filter out all the non-even ones using mod. Right, so here with this lambda, we're saying whatever input, check to see if that mod 2 is 0. So the odd ones will basically get thrown out. And then we're going to call that on our fib list. And then close off the square bracket. So we're going to call this filter on fib with this lambda inside a list comprehension. So when we do that, oops. What is the return type of filter? I think you bring up a good point. Yeah, I think so too. Doesn't actually work with the list comprehension. Where is filter? Takes a function iterable. It returns an iterable. Which is probably not helpful. But yeah, I think Brian is right. I think we need to throw this, instead of in square brackets, I think we have to throw it in a list like that. That's weird. I can do it with dict. Not 100%. Oh, so it worked with curly braces? Oh, you could do it with dict. Okay, okay. You were able to do that with the dict constructor, I see. So as far as what an iterable is, let me try to explain what an iterable is. An iterable is basically this, it's like a sieve, right? So, you know, like a sieve, you can turn the water on and water will start coming out, right? So if we think of a sieve like an iterable, it's able to give us what we want, what we specified, but we haven't turned the tap yet. So we need to do something to also turn the tap, and only then will it start giving us what we want. In this case, whatever we specified here, but with this filter function, is what we're getting out of the sieve. And for some reason or another, and I'm not entirely sure why, when we wrap the iterable in the square brackets, that it's not telling it that, hey, turn the sieve on and actually populate our list with what comes out of the iterable. But for some reason, when we use the list constructor keyword, that is somehow different, and it knows to then actually turn the tap on and start populating the list with what we specified. So here, when we did this and we printed result, we just got this filter object thing, which is how Python represents our iterable before we turned it on, before we've started asking it for things. First, object in memory. The second, yes. So the first is, again, how that iterable is actually represented in memory with its type and stuff and its address. And then, again, we haven't, somehow, for whatever reason, we haven't asked it to actually start giving us what we asked for. And it's like I guess like a syntax thing, where you have to use the proper syntax with it, and then it will know that you mean to actually ask for the things that it spits out. But what's really cool about iterables is this is basically how you would represent like an infinite sequence, right? It's capable of giving you all the values in an infinite sequence, you know, given theoretically infinite time, but only when you ask for it, right? If you think of the reverse of that, there's no way we can just print out an infinite sequence in its entirety, because we're asking for all of it up front, and we want it all there in its complete form, basically, right? Instead, we can represent it as this iterable and just be like, this thing is capable of giving us everything one at a time. So that's kind of basically how programs represent infinite sequences, if that makes sense. If not, don't worry about it. And so another kind of key characteristic of iterables is that they are lazy. And that isn't actually I don't even mean that in a bad way. It means that they are not, they only do work when they need to do work. And before that, they don't do work, right? So again, with this square bracket syntax, we didn't give it the right syntax to tell it to do work. Right. Okay. So we're close to wrapping up. Let me pass you guys the link to the sprint that you guys will be working on. And basically what you'll be doing here is you're just going to be given a bunch of exercises, and it'll outline for you what you want to try to, the Python code that you should try to write in that exercise, and basically get it to do what it's supposed to, what's outlined to do, I guess. There are no tests for it, so you kind of just be like, go and read the, so you'll go into the day one. So for example, if you go in here, well, hopefully that's pretty self-explanatory. So this, well, you can try the shorthand with the 2 asterisks that we saw earlier. You can try using the POW function, I think is what it's called. But hopefully the instructions are pretty straightforward. What's this? Oh, wow. Okay. So there is some stuff here you're going to have to look up. We didn't talk about the sys module. You're going to want to look at the documentation for that. You're going to want to look up what ARGV is. Again, I did not intend to cover everything, because we kind of don't have time. I kind of just picked and chose. So there's obviously going to be concepts in some of these exercises that we just haven't talked about. And so you'll want to go and try to figure out how to get past that hurdle. So again, keep in mind the, well, I'm going to call it the 20-minute rule. So if you encounter a problem or you don't know what something means, allot yourself 20 minutes for research. Anything past that, please holler in the help channel. And I'm going to say for, so let's say for, well, I guess you're tasked with doing all of these today. Okay. So yeah, do your best to get through all of these. Some of them, again, we've talked about some of these. So we've talked about slicing, for example, in lists. We've talked about lists and list comprehensions. So yeah, that's your task today. Get through as many of these as possible. Do your best to get through all of them, because starting tomorrow, we're going to be moving on to the next part of the sprint. And I think we'll go over these during tomorrow morning's lecture. So this repository is for the entire week. It does, I guess, includes multiple projects. Yeah, so like starting tomorrow, we're gonna be doing another project, and besides these little exercises. So again, today, the purpose of today is mostly just to, again, expose some more Python concepts to you and get you practice writing the language. All right, cool. That's about it from me. Thanks for your attention, guys. And I will talk to you all later. Have a good one.